Okay, so our next talk is by Patrick. Okay.
Thanks, Frederic. Thanks for the introduction, and thanks for doing all of the actual work setting up this workshop. I don't think I'm violating a big secret by saying that he did all the hard work. So this talk is kind of the complement of what Michael gave yesterday. So yesterday we heard from Michael how MathLib is managed and how contributions are managed and what are the tooling we have in order to develop MathLib. And the topic of my talk is about coordinating large formalization projects depending on MathLib, or that could be adapted to other proof assistant, or coordinating formalization project depending on whatever is the standard library of your favorite proof assistant. So this is the topic of this talk, but I will still do a tiny bit of history, and this will be a very tiny bit because it's actually very poorly documented. I think it's interesting. All the papers about the great formalization project of the past, they do not discuss at all what I'm the topic of this talk. So I asked questions to older people, and I will tell you a tiny bit, but this is not very reliable. So first, let's discuss very quickly the odd order theorem. So from a mathematics point of view, this is the first triumph of formalized mathematics, of course. The first thing that is important is it formalized a very well understood result. So this is the picture that Asia Maghoubi is always showing of her bookshelf during the odd order project. And all those are textbooks, I mean, even including the proof of the odd order theorem itself. So this will be important for comparison. So it's still a huge achievement to have formalized this, but there was no discussion of reworking the material. Everything was well understood. No major gap was discovered or anything. And there was a very small core team around Georges Gontier. So everything went through Georges, and he's obviously a genius in formalized mathematics. And it was before anything like having a Zulip chat, or even before GitHub. They used SVN. So for younger people, this is something that came before Git. That was a centralized version control, emails, so that things we used to send to other people too, and even physical meetings. And that was kind of a completely different age. I've heard that even rock was not even called the same at that time. So I won't have much more to say about this. I think it's not easily transferable. But of course, it was very much the Cassid role model of just a very disciplined, small team with a very clear boss. So they're very different from the mess we are using in the Lean community, for instance. The FlySpec project, so this is Tom Hale's formalization of the sphere packing in 3D result. There was also a very clear boss and centralized collaboration. This time, the proof need major refactoring of the paper proof, and Tom Hales wrote a whole book called Dense Sphere Packing, a blueprint for formal proofs. That I think was written towards the beginning of the project and used as a new source. So everything was reworked so that it was easier to formalize than the original proof. And so it was, so of course the previous project was in Rock, and this one is mostly in Hall Light with some Isabelle Hall. And I've learned very recently by researching for this talk that there was actually about 700 lemmas that got cash bounties attached to them, but I don't know how much. And it seems that about 10 people managed to get some cash on this. And this is this is mentioned in one of the papers about the project. And of course, Tom Hales trained a lot of people, especially in Vietnam, and he went there and trained people to work on this stuff. And I think again, this was before GitHub, and I don't know what kind of tooling was used. So now let me talk about things I understand and I know from personal experience. So my personal path in this topic was the first big project I was involved in. So not big in the sense of the previous two big projects. I mean, the first non-trivial project was the Perfectoid Spaces project. And this started with Kevin Buzzard and I coming up with this idea of defining perfectoid spaces in Lean. And very quickly, Johan Komlin joined us, and all the discussion was in private Zulip messages, so a single thread of messages that was a complete mess. And there was no clear plan in the beginning. So I knew about what I knew about perfectoid spaces was they were fashionable, and everybody was excited about perfectoid spaces. And I said, I mean, the story was really, I told Kevin, if we want mathematicians to notice proof assistant, we should not do great theorems from group theory from the 50s or the 60s, but we should do fashionable stuff. Perfectoid spaces were the fashionable stuff at that time. And that was the full extent of my mathematical knowledge about perfectoid spaces. And Kevin kind of attended a reading seminar on perfectoid spaces, so he thought he knew what the definition looked like. And there was kind of lecture notes, and we kept discovering missing ingredients. Like Kevin kept posting messages on, I don't know, on Stack Overflow saying we're almost done. And then the next week we realized, oh, there is this line, actually it hides 20 pages of mathematics, and we are not almost done at all. And that was the workflow. And we had a GitHub repository. It was a public GitHub repository, but the discussion was just mostly private messages. And so after finishing, so at some point we finished. So there was a kind of a well-founded situation where at some point we stopped discovering missing ingredients, and the project was done, but I swear that I would never do that again, and that the next project would be better organized. And also I wanted it to be easier to get outside collaborations and more collaborators. And so this is when I set up the theory version project. So that was a project in differential topology, but it's not important at all for my talk. This is when I developed the Lean blueprint infrastructure that I will discuss in the next 10 minutes. And then it was used in the liquid tensor experiment, and people starting noticing this infrastructure, and then it was used in many other projects. Actually, the current list, I think, of projects using Lean Blueprint, I tried to update it yesterday, has about 35 projects. That seems to be an actual project, not just stubs where people started a GitHub repository and gave up after a week. So when you get my slides, I think at some point slides will be posted somewhere, you can find them. All those things are links, and there are many of them, and I think about 35 actual blueprint. So I will show you what they look like, but first I want to tell you the main ideas that I had. So that was back in 2020, and the main aspects I wanted. So I wanted to prepare the mathematical content. So I wanted to first try to write a detailed plan before writing any Lean code. And for this, I took the inspiration. I don't know exactly when I saw Tom Hale's book, but the name Blueprint clearly comes from Tom Hale's. So I wanted to have something like Tom Hale's Kepler conjecture Blueprint book. And that was the first aspect. And I wanted something allowing to manage progress and distribute work among many more people than just 3 people, like in the Lean Perfectoid Spaces project. And the funny thing is it didn't work with the theory version project. And the theory version project ended up being a 3-person work in the end anyway. And part of the reason is because right after we started theory version, Peter Scholze asked us for help for the liquid tensor experiment, and then everybody, including me, went and worked on the liquid tensor experiment, and where there was, I think, at least 15 contributors with non-trivial contributions, and many more with tiny contributions. So it ended up working, but not for my project. That's a bit unfair. And then the third aspect was to dynamically refine the mathematical content. When I wrote the theory version blueprint, before announcing officially the project, I had a kind of a full blueprint. I knew the end was a bit fuzzy, but I was, even at the beginning, that I was really my best effort at writing a detailed proof of this thing. I was expecting to find gaps and mistakes, and I wanted to continuously refine the blueprint during the formalization project. And somewhere. I thought I wrote. And I wanted to get at least some approximation at the end of the project of a bilingual document, having the informal text and the links with the formalized statement, and that was also an idea that I had. And the main principles from the beginning, so the choices I made was, the first one was the source of the lean blueprint should be an ordinary text file with a couple of annotations, but it's just a valid text file that you can compile with a tech engine. And the motivation was I wanted it to be easy to copy paste from existing sources. So for instance, for the liquid tensor experiment, it was crucial because the beginning of the blueprint for the liquid tensor experiment was really the lecture notes by Clausen and Scholze. And this is how it started. And then it inflated a lot. Or the Carlson project by Floris van Dorn and his gang in Bonn. It started with a paper, I think maybe 30 pages long paper. And then Floris told us, no, this is not what we mean by a detailed explanation. And then it raised to 150 pages. And then the formalization work started. But it started from somewhere, from existing sources. And I wanted mathematicians not knowing about proof assistant to be able to contribute to blueprints. I think it never really happened. I mean, there was indirect contributions, but yeah. And you could choose your text, your code editor, any code editor, and not necessarily a code editor having good lean support or good rock support. And of course, from a text file, you get the PDF version for free without asking how you convert a lean file or a rock file to PDF. And the next main principle is I wanted the result of there is a source of the blueprint, and then there is a resulting blueprint. It should include links to all the declaration, and including checking that they exist, and make clear during the formalization project what are the next targets, what is available as a next target for contributors. And and at least get a crude approximation of a bilingual text. And by bilingual, I mean informal and formal. So those were the principles. So what does it look like? So what does it look like in source so this is a part of the sphere version blueprint. Is it big enough or no? So you see there is a definition. So this is a LaTeX file. And there is a just definition environment with a label, and then there are two macros that are specific. Lean OK means this has been formalized, and this is something that human beings put in the source, the text source once something is done, and a reference to a lean declaration. So there is this \lean macro, and if you look at results. And there is also a macro uses that says that this definition of corrugation uses the definition of loop. And this is again human generated. I mean, human beings said this uses the previous definition. And what else? So sometimes there is one proposition on paper that corresponds to many declarations in the proof assistant. So you see here, this is one proposition. And it has how many? 1, 2, 3, 4 corresponding link declaration. And again, information about what is used, and also information about what is used in the proof. So in this case, there is nothing. And the proof also has this lean OK macro saying this was formalized. And then this is what it looks like in the source text file. And in the result text file, this is the file we were looking at. Now looks like this. So it's rendered in HTML. There is a small tick here saying this is OK. So this corresponds to the lean OK. The check mark is the lean OK stuff. There are links. So this graph stuff shows what are the definitions that are used. And there is a source, a link to the source declaration. So maybe in that case, we can do that. So we can follow the link, and it brings you to GitHub. No, not directly to GitHub, first to the documentation. And so you can see what the declaration looks like. And if you really want to see the source code, you can go to the source code. and you'll get on GitHub the source code, but it's it's not yet what I was dreaming of, because this is a completely static stuff. This is just a GitHub page. You don't get any interactive information. So this is why I say it's a very crude approximation to a bilingual document that you get at the end. And maybe let me go back to display maybe what is the most well-known part of this story is the dependency graph that you get. So here, all those / uses macro in the text source that generate this graph that is laid out automatically. And every node is a declaration in the tech file, not in the proof assistant. And you get the statement, you get the link to the LaTeX version and the link to the lean version if it exists. And here it's a finished project, so everything is green. But when a project is ongoing, there is a whole color code for stuff that are current targets, stuff that people can work on. Yes, question.
So if you're already manually marking up which LaTeX declaration corresponds to which lean declaration, wouldn't you auto-generate the lean OK and the uses?
No, that's a good question. So the lean OK stuff is, sometimes there is a lean declaration and you want to link it already, but the statement is maybe not quite right, or the statement is actually only part of what was claimed. I've shown an example where there is one LaTeX proposition corresponding to 4 lean lemmas, and this is pretty common because, in ordinary mathematics, we put many conclusions in the same proposition environment, and in that case, how do you see whether it's lean OK or not? If you, how do you know that you formalize everything? So no, this is human generated. And I will come back to, but I can discuss it now. And a very common question is why do we need / uses when there is already /ref in LaTeX? So we could just look at the /ref, but the thing is that people writing LaTeX code, they are very inconsistent with using /ref, and there are lots of implicit uses and that do not use the reference. Okay. Other questions about this? Okay, so now there are many things that are debatable in this story, and have been debated, and not much changed. So I guess there are debates, but I'm kind of not so open to modification. I don't know. So first, many people were tempted. Some people were tempted to put everything in the same file. So put the LaTeX source and the lean code or your Rock or Isabelle code in the same file. And this has advantages. So you don't have to switch between 2 files and 2 editors. And people who are addicted to Copilot, they feel safer, because if you put the lean code in the file, then the LaTeX code in the file, then Copilot will spit out some nonsense lean code as a suggestion. And yeah, some people feel cozy when this happens. I don't know. So let's say this is a pro. And the problem is that it makes it harder for people who don't know the proof assistants to contribute. But again, to be honest, it never really happened that people not writing any lean code contribute directly to a lean blueprint. And no, something that is much more serious is that editor support is very weak. If you have something that is either a tech file with, that wouldn't work. If you have a lean file with tech code in comments, I don't think there is any editor that will give you LaTeX support in completions and compilation and linting of LaTeX code and so on. So, but still, there is one example of a project that uses that. So the prime number theorem and beyond project. There is a Python script by Jan Josling that extracts a tech file from lean file. So, oops, no, that's not what I wanted. So an example of this is, so you see, this is a file from their project. And you can see here there is a comment, which is a special markup, this -%%, and then a tech code. And and then some lean code, some lean code, some lean code. And this is a lemma, again, comments with a special tagging. And this is turned into, so there is a Python script that reads these lean files, get rid of everything except the specially tagged LaTeX code and generates the blueprint. And okay, so this has been attempted, and they are happy about this. So for some people, this works. So this we already discussed. I mean, using \ref instead of \uses. So it's a huge loss of flexibility and precision. And I mean, in the beginning, what happens is people see these \uses and they complain about it. And then after trying using it, they realize the overhead is completely negligible. And the time you spend typing \uses is completely negligible compared to any other step of the process. And also the time spent maintaining those \uses. So of course they break. Sometimes you rename a lemma and you need to fix that, but this is completely negligible. And every time I say we could still implement warnings when there is a \ref with no \uses, but I've never done it because it was never an issue actually.
I don't understand that. I mean, nobody, for example, use ref for definitions, so this would never work.
Yeah, but there are still people who complain about that. Yeah, I agree. I mean, when you state, I don't know, every zero of the non-trivial zero of the zeta function is on the critical line, you don't have a \ref to the definition of the zeta function. I don't know. I don't know. More serious debate, where do we put discussions? So the blueprint infrastructure actually has a future where every item that appears in the graph or every LaTeX declaration can include a link to a GitHub issue. And I think nobody ever used it. And there were tests with that. Maybe people no longer know it exists because it's been forgotten. So maybe this will change after this talk. So what we do a lot more is discussing on Zulip chat, or that could be some similar chat. And there have been discussion of trying to add a commenting framework like Discourse, where you can put inside your HTML file, have a small JavaScript library that allows you to add comments to the web page. But this, again, this never went anywhere. And I mean, finding the right balance is really tricky because you don't want the thing to be extremely formal, where you're not allowed to discuss this lemma except at this place. I mean, if you try that and then people still discuss it elsewhere and it becomes a mess, and we never found a better way. I will show you later what people actually do. We don't have a very good answer to this question. And then there is the issue of huge projects. So for instance, Fermat's last theorem is just too big. If you want to try to put everything on the same graph, it's just completely impossible to read. I mean, the graph that I showed earlier, and that's really the right size. I mean, you can still see the structure and almost read the labels if you're younger than I. And you can, this is manageable. Already, if you go to the Carlson project, I think it's already becoming less useful, and especially the structure of the automatic layout is a bit weird. So there is work in progress about. So you can already have like one graph per chapter, and this is what the liquid tensor experiment did, but it's not super satisfying in the case of Fermat, and so we are working on this. Yes.
I've seen for other libraries a dependency graph was not at the level of kind of individual definition, something more at the level of like files or something like that. Or like you can kind of zoom in or things like that.
Yeah, so this is the kind of thing we want. And again, the graph is really, it's not a graph of the lean file, it's a graph of the tech file. If you look at the corresponding graph for the lean file, it's actually a huge mess because there are many more lemmas and that was, again, something that I decided explicitly at the very beginning. I wanted to have a graph that human beings can use to see where we are and what is the available next target. Maybe a more recent debate is where are we still using LaTeX in 2025? So very quickly, I mean, one point is I started this in 2020, types didn't exist. So there was not an option to use types instead. And if we wanted to switch now, I think the HTML export is not good enough for this. For instance, it exports everything in a single file. And I don't know if it will ever be flexible enough. But that's something we could experiment with, although most mathematicians still use LaTeX anyway. So we would also lose the fact that anybody can write a blueprint because everybody knows LaTeX. But maybe, you know, if I redo this talk in 5 years, the situation will be completely different. So what is the current implementation stack? At the bottom, there is Plastek, which is a Python LaTeX compiler. And the crucial thing is that really has an intermediate representation. So the Plastek will parse your text file, I mean, assuming it's not too complicated. And then you get some intermediate representation with the sections, all the environments, and you can manipulate this intermediate representation. And there is a plugin system, so you can write plugins. And then, for instance, one of those plugins is Plastek Dev Graph that I wrote. And this allows you to make the graph. So it contains in particular the /uses macro. It draws the graph. It has infrastructure to customize it, but has nothing to do with Lean. And then on top of this, there is the Lean Blueprint plugin that adds the /Lean and /Lean OK links to Lean and stuff. And also has a command line client to set up projects. And then there is a tiny Lean library that simply checks that declarations exist. So when you have a /Lean linking to a Lean declaration, we want the continuous integration to be able to check that those declarations indeed exist. And this is not done from Python. This is done by just Python calling a small Lean program. And the interesting thing is that the first 3 items are just Python plus JavaScript. The first 2 have absolutely nothing to do with Lean. And the third one, I mean, it has very little to do with Lean. It would be very easy to adapt. And the fourth item is Lean specific, but it's literally, I think, a 10 lines long program written in Lean. So everybody is welcome to adapt this to their favorite proof assistant. It's not a lot of work at all. Although, again, you could debate whether relying on LaTeX and on this Plastek library is 20 years old, and so I'm the current maintainer of Plastek, but I was not there when it started. I think it started with Python 1.3 or something like this, and there are still traces of Python 1 in the code, at least morally, and so it's not fun to maintain this thing. And it's a huge library, and so I kind of hacked stuff on top of it, but it's yeah. I mean, it works, and it's really. It's used also for people who know the Stacks project. The website in algebraic geometry from Stacks project also runs using Plastek. So now, what is the current typical project life cycle in at least in the Lean user community? So first, people can use a GitHub template. So this is the work of Pietro Monticone, who is a student in Italy. So you can just go to GitHub and click this button, use this template, and this will create a scaffolding for your project. And there are instructions about running the Lean Blueprint client if you want a blueprint. So it will tell you how to install Lean Blueprint and then type Lean Blueprint new. And this creates, again, the scaffolding, all the boilerplate, including setting up continuous integration so that it builds a website and deploy it on github.io by default, but you could also deploy it. So this is Floris deployed it on his website. The other ones are just on github.io. So all this is handled by the template and the command line interface. And then, of course, you need a project leader. So it doesn't have to be Georges Gontier or Tom Hales. but you still need someone who cuts the project into small pieces and states stuff. And this is also one of the reasons why the theory version project was not moving so fast in the beginning. I was not working hard enough as the project leader, and I realized that a bit too late, especially when I saw Johan Comlin doing it right with the liquid tensor experiment. So like working 10 hours a day and just providing lemmas to prove to everybody. And it's very easy very important to resist the temptation of filling easy proofs. So you should leave lots of easy stuff to prove for new contributors. And this really helps with parallelizing the work, but also onboarding and training the new contributors. And this again is something that I was bad at doing in the beginning, and other people do it much better. And then you need tracking tools. So the way we usually do that is the most popular method is to have a Zulip thread called outstanding tasks. So here is an example. If you go to the Carlson's project, so first in the lean Zulip you can have channels dedicated to projects. Like you see, all those channels are so this one is the Carlson project channel, but there is an analysis one is a book by Terry Tao, batteries as a channel, equational project, FLT, all those are formalization project. And you can see messages like this one. So this one is a bit extreme. This is a really long list of tasks. But Floris, who is leading I guess it's done now, the Carlson project, just wrote endless list of small lemmas, and people claim those lemmas. Like you can see that task 74 was to prove lemma 7.2.3. Maybe I can do that bigger. And Jeremy Tan said, I want to do that one. And the way he did that was, I think, writing a message somewhere. And here you can see Bolton Bailey said, I'd like to try 10.1.1, and Floris is happy about it. And then the post is updated. And the post, I mean, if you look at the edit history of the post, I mean, probably you'll see dozens of edits by Floris modifying the list. And I mean, it looks like an extremely primitive project management, but it's already, I mean, much better than doing nothing, and or having one giant discussion in a single thread. Okay, so people do that. There are also the idea of using GitHub projects. So this is infrastructure that is just native to GitHub, and it could be, I mean, it could be something else than GitHub. I mean, in the lean community is unfortunately completely addicted to GitHub as opposed to open source alternatives, but this is very hard to change. I mean, people in open source know that very well, but I'm sure GitLab has similar stuff, but people simply don't use it. So you see there are, I mean, here are 4 columns, unclaimed outstanding task, claimed task. So this is in the equational series project in progress. And those things are moved, I mean, those are managed semi-automatically. Like if you look at why this is claimed, it's because so Terry Tao wrote a description of the task, and then someone, yeah, I don't know who is this command master, wrote simply claim in the message. So it looks a bit rude, but actually it's, I mean, there is a bot that reads this message and move it to the next column, move the issue to the next column. And this is all done using GitHub workflows. And GitHub workflows is just awful. I mean, those are YAML files, mixing, so programming using YAML and also shell scripts. And I mean, I hate writing such things, but there are people who are patient enough to do that. And this is how those things work. So you see, this is the claim issue.yaml. So this is presumably the part that checks if a command contains only claim and then does something. And yeah, so I think in the equational project, they've been happy about this workflow, and with GitHub workflows moving stuff from columns to columns. And so this is also something you can try in your project. And you can see, yeah, they completed 197 tasks, so probably this worked as a management tool. So what's next in the project lifecycle? Then there is the infamous formaflip folder issue. So I can show you the original one in our case, but I don't want to claim any credit for inventing procrastination, but in the Lean Perfectoid Spaces project, we had this folder for Maflib, and it was just all the stuff that should have been put in Maflib directly, but we were too impatient, or maybe the code was not good enough. And you can see those 6 years ago, we put that in algebra.lean, and this is even Lean 3 code, of course, 6 years ago. And I don't know, maybe nowadays this is in Maflib, but not thanks to us, because it stayed in that for Maflib folder. So it's really, I mean, it's really hard because there is a balance. You want to move fast and putting stuff inside Maflib or inside MAFComp if you're using Rock is, I mean, it takes time. The code quality standards are high, and you're excited about perfectoid spaces, not about algebra maps. But then it stays forever. And I won't mention who did the work and what remains in this formaflip folder. You can just investigate. But yeah, it's hard to do that. So recently there have been experiments, I think, pushed by Yael Didis, to have an upstreaming dashboard. So what is an upstreaming dashboard? So this is the one of the toric variety project. So there is a web page that is generated automatically, and what this web page lists is, in the case of the toric project, it's every file in the toric project that imports only Maflib file. So not other files from the same project. And so those files may be good targets for upstreaming, so contributing back to Maflib. And it also lists currently open Maflib pull requests touching files imported by those listed files. So it's a kind of a weak version of some information about whether there is activity related to those files. Yes, Michael?
I think it's slightly different. The pull request touching this exact same file, not the import.
No, I'm pretty sure it's not. So for instance, this one, toric Maflib ring theory adjoint root. I think if I don't know, I click that.
I think these are all pull requests touching matlib.ringroot.adjoin.
I think it's okay. I'm not sure. I think it's touching files imported by this thing, but I'm not quite sure. But there is some mechanism, and again, it's I mean, some Python script is just scrapping the imports and getting also information about the currently open Maflib pull request and trying to display useful information. I mean, I don't want to say it's bad in anywhere when I say it's just some Python script. I mean, I love writing crappy Python scripts that are very useful to me, and this is not at all. I don't want to complain about anything. I mean, people really, what I'm showing you today is, I mean, all the little tricks that people try to use to manage this formalization project depending on Maflib. And there is not yet it's clear that there is not yet a final, fully professional workflow, but people are experimenting, trying stuff. And maintenance after the project completion is, of course, difficult. It's the famous bitrot issue. I'll show you one trick that I'm using a lot with the Sphere version project. It's just miraculous appearance of maintainers. So if you look at what happens in the Sphere version project, I mean, the project was done like 2 years ago or 3 years ago. And what are the commits? I mean, you see Ruben bumping to a new Lean version. And you see Pietro Monticone also doing so, Ruben van de Velde and Pietro. And you see Michael, so this is not obvious, but this is Michael Wolfgang sitting here, just doing maintenance on the project. And where are the actual author of the project? I did something, remove an old proof 1 year ago, not 1 year ago. And I don't know. I don't know why those people help like this. I'm very grateful, and I didn't ask for anything, right? And they help maintaining the process. This is great. So I recommend this trick. So now, what about the future of project management in our community? So two big things that are changing the game quite a bit is, so the first one is the Lean FRO, so the Lean Focused Research Organization that was founded in July 2023. And so this is just an organization devoted to improving Lean and making life of Lean users easier. And so they got money from industry and donors, and they are on a 5-year mission to improve Lean and also reach self-sustainability. But what is important for us, so they do a huge work to coordinate Lean and MAFLIB modifications, but this is kind of outside of the scope of my talk because this is really MAFLIB. And they also work on reducing technical debt, so especially things related to going from Lean 3 to Lean 4. So if you're interested in that, you can follow. We've got information posted regularly on Zulip by bots saying how many porting nodes remain in the library and how many were removed in the past week and things like that. So this is really about MAFLIB, but also they work on helping downstream projects. So working on GitHub Action instead of having GitHub workflows that are copy-pasted from one project to the other, that they try to develop reusable actions to run continuous integration, trying to automatically update to newer Lean versions. They have the downstream project reports, where again, this is some bot that posts comments on Zulip about what is nice and what is not so nice in existing projects. So you can see, for instance, that the Fermat-Last theorem is using as a latest toolchain this 4.22. It detected that it has nice workflow, and some things are not so nice, like consider adding a Lean driver. So it posts analysis of what is nicely set up and what is less nicely set up in a bunch of downstream projects. And then they kind of, I think they also kind of want to replace, at least partly, the Lean blueprint infrastructure in the third-year roadmap, so roadmap of the Lean FRO for this year. There is literate programming and next generation user experience, and it includes enhancing Verso, which is the, I mean, I don't have to describe time to describe Verso, but I mean, you could read that paragraph as saying that they will do properly what I tried to do in the Lean blueprint infrastructure. So maybe this will be improved too. And then, and I'm almost done, there is future help coming from the MAFLIB initiative. So this is brand new. This was announced on July 24th. So Alex Gerko donated $5 million to just help MAFLIB for 2 years. And there are several goals, but the one that is relevant to that talk is work on scaling the infrastructure to support an ecosystem of math library depending on MAFLIB. So this is exactly just putting resources into all the topics that I discussed today, and project management and infrastructure. And so they will pay people to work on that kind of thing. And I think, yeah, I think I'll stop here. Yes.
I have a question on kind of the workflow you have is basically you do a mass proof and then you turn it into a lean proof, basically. And like, for instance, I hear Martin Escardo on the internet is very proud that his main workflow is that he just opens Agda and then starts playing around with Agda, and at some point he has a mass proof and he turns that into a mass paper. So it's kind of a very different workflow that like he's experimenting with the proof assistant first, yeah, while you're kind of starting with at least a good idea of the math proof before writing any lean. And I was wondering whether like, I guess there's different tooling or different like, what are your thoughts are these?
I think the main difference is the kind of mathematical area where you're working on. I mean, the kind of mathematics that it does is very good for this, and it's fine. I mean, it's a very nice, interesting work, and I don't know much about, but I mean, I think it's also more common in programming language theory, if I understand correctly, that people work also with proof assistant maybe more in real time. So it's true that the kind of mathematics that I do and that the projects I participated in were really, I mean, kind of already well understood mathematics, but well understood, there is a wide spectrum of well understood. I mean, this is why I said in the beginning, I mean, you see from the Fay-Thompson to the other order theorem was really well understood in the sense that there were textbooks about it and they didn't find any major gap in. And if you go to for instance, the liquid tensor experiment, I mean, it was sufficiently not well understood that the author asked for help to check his proof. I mean, normal human beings would have been fully convinced. I mean, he was really very, very careful, and there was nothing major discovered during the formalization. But still, I mean, Peter Scholze now claims that he understands the proof much better after talking to us for 6 months about it, and so this already improved things. In the sphere inversion project, that was the project that I initiated about mathematics that I claimed I understood very well. I was kind of surprised at the end of the project and how I was incapable of writing precise stuff without the help from the proof assistant. So if you compare the blueprint at the beginning of the project and at the end of the project, I mean, maybe I should erase the GitHub history of the first version of the blueprint, because there were things that were, I mean, what is very hard in this area is to write lemmas that are both 100% correct and 100% what you need. I mean, it's very easy to do one of them, but the things that are almost correct or almost sufficient for your purpose, but having really things connect exactly and being 100% correct, I was not able to do it on paper. And for mathematics, I understood. It's not like with perfectoid spaces where I was learning as I went. So, but maybe, I hope there will be more and more areas of mathematics where it's useful to use the proof assistant as you work. So maybe some kind of more computational stuff could benefit from that. Yes, Michael?
I also have an idea to your answer, if I may. So I understand these blueprints as enabling massive collaboration on large scale. That's different than one person working alone.
Yeah. Yeah, that was really a goal from the beginning of the blueprint project, was to allow more massive collaborations. Of course, there are other options. You can also work on more elementary things like this. This is what the equational theory project did. Terry Tao chose this topic because it has no mathematical prerequisite at all, and he hoped to attract a lot of people, and indeed it worked, and he attracted a lot of people with all sorts of backgrounds, and they worked. I mean, they did the research at the same time they were formalizing. But again, it's very specific kind of mathematics.
More questions? Or we continue the discussions perhaps during the coffee break?
Yeah.